Day 6 of AP Review, where we look at applications of calculus, specifically related rates and modeling scenarios, okay? So we start again with the average value of functions. Recall the average value of function over closed interval AB is given by 1 over b minus a multiplied by the definite integral of f from a to b. For function f, lowercase f with an antiderivative uppercase f, we recognize that the average value of lowercase f over an interval is equivalent to the average rate change of its antiderivative. Okay, so the average value of f is equal to, over an interval AB, is equal to the average rate change of its antiderivative over that aforementioned interval. Again, the idea being is that by the first fundamental theorem of calculus, this definite integral is equal to the change in our antiderivative over that said interval. Related rates. To solve related rates problems, write down all known values and the associated derivatives. Remember if our derivative is positive or negative. And then identify our unknown. Determine from your unknowns in the geometry of the problem an equation that relates all knowns/unknowns. Right? Triangle, cylinder, sphere, similar triangles, inverted cone, etc., etc. Substitute any values that are constants into your equation and differentiate the equation. Solve the resulting equation for your unknown. Remember that they do like to throw related rates problems in with differential equations problems. So in this case, you proceed as usual, but then your solution for your unknown derivative is going to be a function of the original variable, and then at that point you solve the resulting differential equation if asked to do so. Keys for certain problems. For spherical volumes and surface areas, the two equations are related by the radius r. And then for inverted cones, remember to use similar triangles to relate r and h. Modeling real-world scenarios with calculus. Key things to watch out for. Quantity/amount. The function is not a derivative. Rate. The function is a derivative of the quantity function. To attain a rate from a quantity, you're going to differentiate. To obtain the change of quantity from a rate, you integrate. It's a nice little rhyme there. And then this is a little confusing problem that we've gone over before. Remember, it's quite confusing. There will be problems where ask you, is the rate increasing/decreasing? If that happens, it's not asking you for the first derivative of the quantity. It's asking you for the derivative of your rate. So what you do is you look at your rate function, and you take the derivative of your rate function, which will be the second derivative of your quantity function. So problem is asking for acceleration, i.e. the rate of expansion of the universe, increasing or decreasing. So you need the derivative of the rate function, the second derivative of the quantity function. So if you're given the rate function to start with, you take the derivative of it to get your second derivative. Let me back up here. So if it gives you a rate function, if it asks you increasing or decreasing, you take the derivative rate function. If it gives you a quantity function and it asks you is the rate of the quantity increasing or decreasing, then you take the second derivative of the quantity function. Derivatives. Okay, f prime of a represents how much a quantity f is changing, i.e. increasing or decreasing at the time t equals a. Integrals. Okay, the integral of a rate function represents the change in the quantity f from t equals a to t equals b. Whereas this equation right here is our average value equation of a function f. It represents the average value of f. It could be a rate or a quantity from t equals a to t equals b. So as an example, if f is a velocity function, okay, which is a rate, then the average value is telling you the average velocity from t equals a to t equals b, okay, where x equals a, x equals b. Whereas if you have a quantity, let's say like a quantity is like the amount of bacteria in a petri dish. That's what f represents. And then this equation right here represents the average quantity of bacteria from t equals a to t equals b. Okay? Same way right here, if f prime of t, let's say this is the rate of change of temperature, then integrating f prime of t gives you the change in temperature from t equals a to t equals b. Integration gives you the change in a quantity. Average value gives you the average value of your integrand from a to b. And that covers day 6, very briefly, of our AP review.